All right, this was the lesson that was in your textbook, and it kind of breaks down for you a little bit more the steps to solving radical equations, and the problems in this lesson are not too bad. So I'm just going to go through it. You want to isolate the radical, so in A you would divide by 2 on both sides, square both sides, and subtract by 1, and get 3. Now don't forget, we have to check our answer every single time. Make sure that it's not extraneous. So will this equal 4? Well, 3 plus 1 is 4. Square root of 4 is 2. So 2 times 2 does equal 4. So that is the solution. In this case, same idea. Isolate the radical. Add by 1 on both sides. Cube both sides. 3 cubed is 27. Add 9 on both sides. Divide by 2 on both sides, and you get 18. If we check that in the original, does the cube root of 2 times 18 minus 9 minus 1 equal 2? 2 times 18 is 36. 36 minus 9 is 27. Cube root of 27 is 3. 3 minus 1 does equal 2. That's the solution. Okay. Now it just builds up in difficulty. So here, again, the radical is isolated, so I'm just going to square both sides. On the left, that's x plus 1 times x plus 1, so that's x squared plus 2x plus 1. On the right, that's 7x plus 15. Move everything to one side now that I have a quadratic. So that's going to be negative 5x. That's going to be negative 14. Factor, so two numbers that multiply to negative 14 but add to negative 5 are negative 7 and 2. So your two solutions are 7 and negative 2. However, when you plug in negative 2, you get a false equation. So the only solution is 7. Okay. Here, I have one radical isolated, so I'm just going to immediately square both sides. On the left, I have root x plus 2 plus 1 times root x plus 2 plus 1, and on the left, 3 minus x. When I FOIL the left-hand side, first I do root x plus 2 times root x plus 2, which is root x plus 2 squared, which is just x plus 2. And when I do outer and inner, I get 1 root x plus 2 plus 1 root x plus 2, which is just going to add to 2 root x plus 2. And then 1 times 1, 1. Isolate this radical now. So subtract by x on both sides. And you get negative 2x. Combine the 2 with the 1 and you get 3. Subtract 3 on both sides and these will cancel. So you get 2 root x plus 2 equals negative 2x. Divide by 2 on both sides and you get root x plus 2 equals negative x. Square both sides and you get x plus 2 equals x squared. Move everything to one side. Two numbers that multiply to negative 2 but add to negative 1 are negative 2 and positive 1. So your two solutions are positive 2 and negative 1. However, the positive 2 is extraneous, so only negative 1 is a solution. Okay, so those were all similar to the other lessons, just different problems. This is where we saw something new. So here you don't have a radical equation, but technically it is, because we know powers that are fractions correspond to radicals. All right? Now I'm not going to write it in radical form because it's actually easier to leave it in exponential form in this case, but the steps are the same. I want to begin by isolating the exponential component of the equation, which in this case means subtract by 2 on both sides. So now I have 2x to the power of 3/4 equals 8. Now to get rid of that power of 3/4 so that I can solve for x, all I have to do is raise both sides of the equation to the power that's the reciprocal, that's the opposite of the 3/4. Because then, when I do power to a power, I have to multiply the exponents and everything cancels. So that's the idea. So what I'm left with on the left-hand side is just 2x. And then on the right-hand side, if I want to simplify this further, I should put it in radical form. So the cube root of 8 to the 4th power. Now the cube root of 8 is 2. So I have 2 to the 4th power. 2 to the 4th power is 16. So x equals 8. Now again, we want to check our answer. So does 2 times 8 to the power of 3/4 plus 2 equal 10? 2 times 8 is 16. The 4th root of 16 cubed is how I would rewrite that. What number times itself 4 times gives me 16? 2. 2 cubed is 8, and 8 plus 2 does give me 10. So this is the solution. Okay, now 5. I could rewrite this as the square root of x plus 30 equals x, but let's leave it like this so we can continue practicing solving when it's a rational exponent. So if I have x plus 30 to the 1/2 power, in order to get rid of that 1/2 power, I have to raise both sides to the reciprocal, so 2 over 1, which is the same as 2. These cancel. I'm left with x plus 30 equals x squared. Move everything to one side and factor. And you get x equals 6 and -5. But when we plug it into the original equation, only 6 works. So that means -5 is an extraneous solution, and 6 is our only solution. All right, almost there. Solving solving radical inequalities is basically the same as solving equations. The only difference is that if it's an even root, so if it is an even root radical, meaning square root, 4th root, 6th root, and so on, you need to ensure there won't be negatives under the radical. Which means, we'll find out what it means. Let's solve this. So isolate the radical, divide by 3 on both sides, and you get 4. Square both sides, and you get x minus 1 is less than or equal to 16. Add 1, and you get 17. Now, what this means is that any number less than or equal to 17 is a solution to this inequality. However, that's not true, because if I continue to go more and more negative, more and more numbers less than 17, I will eventually get numbers that cause this radical to have a negative solution, or to have a negative under the radical. So how do I address that? I take whatever is under the radical. In this case, it's just x minus 1, but could be anything. I take whatever is under the radical, and I say it has to be greater than or equal to 0. Because you could have the square root of 0, that's fine. But you can't have anything less than that. So I need things greater than or equal to 0. When I solve this, I get x has to be greater than or equal to 1. And so the combination of these two things is my solution. X can be anything greater than or equal to 1, but less than or equal to 17. This is how you would write that in set notation. and then an interval notation like this. So this is set notation, interval notation. And that's it.